So I'm hoping the voice holds out. We'll see how long it lasts. So this talk actually builds on Chris's talk and is sort of a segue into John's talk, because he's going to be talking about FreeNAS. So we're going to continue on the theme of ZFS, and my talk will just look at the graphical tools in PC-BSD and FreeNAS. And usually when I give this talk, a lot of users are not familiar with ZFS. So I talk about the features first and then show where in those operating systems you can implement them. So if the first part is review, just bear with me, and we'll look at some of the utilities. So my name is Dru Lavigne. I'm also with iSCSI, and I'm the person who writes the FreeNAS User's Guide and the PC-BSD Handbook. So if you find any mistakes in those, feel free to contact me, and feel free to assist in improving the documentation. Yeah. Okay. So we're going to discuss some ZFS features. We're looking at the most recent versions of both FreeNAS and PC-BSD. And as Matt was talking about this morning, they are both on feature parity with the latest OpenZFS feature flags. So if we just take a very quick history of ZFS. So this was a modern file system that was specifically designed to add features not available in traditional file systems. And it was specifically designed to work with modern hardware and to be scalable as hardware continues to scale. As you probably heard, it was originally developed at Sun with the intent to open source. Things got a little funky during the Oracle acquisition. It was sort of up in the air what is going to happen with ZFS. Fortunately, OpenZFS has solved that, and that we still have some of the original engineers, as well as companies and organizations that have vested interests in ZFS contributing to ZFS. And as Matt mentioned, we no longer have version numbers, we instead have feature flags. If we take a closer look at what ZFS is, it is a 128-bit file system, and one of its more compelling features is that it's copy on write. So that means that you don't, when you modify a file, you don't overwrite the original disk blocks. You instead write the modified file elsewhere on disk. It supports a very large pool size as well as file size, and it's not expected in any of our lifetimes that we'll actually exceed that size. One of the things, if you haven't used ZFS before, that takes some time to wrap your head around, if you're used to traditional Unix file systems, you're used to thinking ahead of time, how big am I going to make root? How big will USR be? How big will var be? Because these are created at file system creation time, and they're a static size. You're basically stuck with the size that you formatted the disk with. With ZFS, you instead feed your disks into a pool, and then you have the flexibility of creating file systems from that pool as you need them. So that brings up the question, what's a pool? Well, basically think of it as the root of your file system. You can create file systems from that pool as you need them, and we'll talk a bit more about that. When you are adding multiple disks to a pool, you're creating something known as a virtual device, or a vdev. And when you're looking at larger storage involving multiple disks, you do want to spend some time at the beginning familiarizing yourself with what is the optimal number of disks to create per vdev. Because you start getting into things like, if I have to replace a disk, we're going to have to resilver that pool. And you don't want to be resilvering 40 disks at a time. You're also, as the information gets written to this, you also want to be able to optimize that. So you don't just throw in a whole bunch of disks into your pool. You actually design that ahead of time. And then as more capacity is needed, you can stripe in. Typically you're striping in identical vdevs. So you sort of want to plan ahead of time how you want to do your storage. Which brings us to the RAID Z levels. So ZFS was designed to take care of the RAID itself, to overcome some of the built-in problems inherent with hardware RAID. So for example, you may have your data written to disk before the parity information gets written to disk. That's a problem known as the write hole. It's also possible when you're relying on your controller that it will silently write corrupt data over time before the controller gives you an alert. And ZFS was designed to overcome that. The other nice thing about ZFS is it was designed for commodity disks, so you didn't have to buy expensive RAID controllers. It can still be used with a RAID controller, but typically you're putting the controller into JBOD mode. So you're giving ZFS control over the disks. Right now there's 3 different RAID Z levels, and the number after the Z tells you how many disks you can lose before you lose your data, and that number is per vdev. When ZFS is doing a RAID Z, parity blocks are always distributed across all of your disks. So it's not like traditional RAID where it depended upon the type of RAID, how parity was written. And for each of these, as I go through these, it'll tell you the optimal vdev size. So if you're creating a RAID Z1, typically you're feeding 3, 5, or 9 disks at a time. RAID Z2 is similar, except it's double parity, so that means you can lose up to 2 disks per vdev. And this one is optimized for 4, 6, or 10 disks. And RAID Z3 is triple parity. You can lose up to 3 disks per vdev. And this one is optimized for 5, 7, or 11 disks. If we take a look, how would I go about creating a pool on a FreeNAS system? So FreeNAS, the operating system itself is separate from your storage, so it actually lives on a USB device. So creating your pool is something you do post-install, and we have something in the storage tab called ZFS Volume Manager. And this one has the logic built into it to assist you in creating an optimized Z pool. So when you're creating a pool on FreeNAS, you give it a volume name. In this example, I had 5 disks, and I've selected 4 of them, and I still have a disk left over. So it tells me how many disks I have and what their sizes are. As soon as I select a number of disks, it will go and create the optimal RAID Z type. So here I've selected 4 disks. And if we look, RAID Z2 is optimized for 4 disks. So it's selected a RAID Z2. It'll tell me what the capacity is after the storage capacity, after the parity data. And if I'm ready to go, it'll remind me that we're actually formatting these disks if you decide to go ahead. When you're creating a pool using the ZFS Volume Manager, if you decide, well, I have 4 disks, but I'd rather create a RAID Z3, it will let you do that, but a red message will say this isn't quite the optimal configuration, and there's a hyperlink to our documentation that shows what the optimal configurations are. Yes?
How often do you need for use of space performance?
Both. If I'm on a PC-BSD system, we create the pool during installation. So this is part of your installer screens. By default, PC-BSD assumes that you just want to install it on your primary disk, and that's all you want to do. So you have to actually push a button that says, I want to customize. And in this example, I did this in VirtualBox, so I made a whole bunch of virtual disks. And I have a choice of either just installing on my primary disk, or I can take advantage of other disks. So if I wanted to create either a mirror or a RAID Z, I would check this box. At that point, this drop-down menu will stay grayed out until I start selecting disks. And as I select disks, it will give me a note down here saying what it's optimized for, and it won't let me select from the drop-down menu an option that I don't have enough disks for. So if I wanted to create a RAID Z3 and I only had 3 disks, RAID Z3 would not show up in the drop-down menu. So again, it's trying to assist you in creating an optimal pool. So that's getting your pool created. A couple of other terms that we deal with ZFS is you'll often hear people talking about the ZIL, or the ZFS intent log. So think of this as basically the area where writes stay until they actually get written or committed to the disk. This automatically happens in RAM. Depending upon your workload, you may benefit from adding an SSD to be a secondary log device. But one of the things you want to be aware of is what type of applications are writing to your disk. Because a secondary log will only help with synchronous writes. If your application is doing asynchronous writes, it's not going to add any value. Typically, this is something we worry about on a server or a storage device. So FreeNAS gives us a utility called zilstat, which can be run from the command line. And you can run that, and it will let you know if the system would benefit from having a secondary log device. And our documentation explains how to run that utility and interpret its results. The other thing we deal with is the ARC and the layer 2 ARC. So this is for your read cache. And we all know that it's faster to get data from RAM than to have to go to disk in order to read. So basically, it's your read cache. Again, FreeNAS gives us a couple of tools to see if you are getting the best out of your read cache. So ARC stats have actually been added to top, so you can just run top. And we have 2 command line utilities called ARC summary and ARC stat, where you can monitor in real time what's happening with your ARC cache. Just like the secondary log, you can add a secondary ARC, or the L2 ARC. Again, it should be installed on a fast device, such as an SSD. And when you're dealing with these, the general rule of thumb is always throw as much RAM as you can. You can never have too much RAM. And an L2 ARC is not a cure for not having enough RAM. You will actually decrease performance if you don't have enough RAM and you add an L2 ARC. So in FreeNAS, if I want to go in and add either a secondary log or an L2 ARC, I go back into my volume manager. I could have done this at pool creation time just by selecting an SSD. But in this case, I already have created a volume, so I'm just going to say I want to extend this volume by either adding a ZIL or an L2 ARC. And I select the SSD, and I can just extend the volume. If I'm on a PC-BSD system, this is something I can do post-install. So in Control Panel, we have a new utility in 10. Called Disk Manager, where you can manage all of your ZFS stuff. If I go into a ZFS pool and select my existing pool, I can add a log device or add a cache device. And it will ask me which SSD to add. When we get into, now that I have the pool, how do I start dividing it up? How do I start using my storage? So you can, as you need them, add something known as a dataset. And a dataset, you can think of it as adding another file system. It has some really cool features in it, though, that makes it really ideal for getting the most out of your storage. So file systems are dynamically sized. You can create them as you need them on the fly. A data set allows you to set permissions, just like you would on a folder. But what's really interesting with data sets is you can set properties. And typically you're setting things like quotas. You can set reservations, you can set compression. It's a whole bunch of properties that you can set. And a well thought out design can help you optimize the storage for the type of data that you're storing. And you can do all kinds of things with data sets. So if you want to use data sets for permissions, you could, for example, create a data set for each user and then set permissions and shares for that user on their data set. If you have certain types of users that would benefit from a disk quota, so they don't hog the whole system, you can set quotas for that person's data set. You can create data sets for certain types of shares or for storing certain types of data. So you may want to put your media on a data set, put files, data files on a different one. When you get into the different types of properties you can set, there's literally dozens of them. If you're on a FreeBSD based system, you can just do man ZFS. It describes them all in gory detail. And if you're not on a ZFS system, you can read them online man pages. On a FreeNAS system, it takes approximately half a second to create a data set. It actually takes longer to move your mouse to type in the name of the data set. So once I have a volume, I click on the Create ZFS data set. The only value I have to give it is a name, and typically you give it a name that's useful to remind you what this data set is for. If I want to, I can play with the compression level, some of the properties, but basically I usually just give it a name and click Add Data Set. And you can create as many of those as you want. On a PC-BSD system, I can either do this during installation or afterwards. So in the installer, in the screen after I've created the pool, it will show all of the default data sets. And what we recommend on PC-BSD is don't touch the default ones because they're tied into the utilities. So as Chris was mentioning, the boot environments, that's all tied into data set names, life preserver. But you can go in and add as many as you want. And you just simply click Add, give the data set a name, and if you want, you can set some of the properties while you're in there. If I want to do it post-install, again, I'll use that Disk Manager and Control Panel. So I go into the File Systems tab. It again shows me all the default data sets. I click the Add button, and I can go in and give the data set a name and set some of the properties. And again, create them as I need them. The other type of file system that you can create in ZFS is something called a zvol. And basically think of a zvol as a virtual raw block device. This is something that you're going to share out and you're going to format with another file system. So the most common use case is to use it for iSCSI, but you can also use it to host foreign file systems. So if you need access, say, to an ext file system or an NTFS file system, you could do that. The benefit of using zvols is even though that area of disk appears to be formatted with another file system, all the features of ZFS you still have in the underlying disk blocks. And we'll talk a little bit more about those features. Right now, PC-BSD doesn't have a way to create zvols that I know of. I don't think we're doing those yet. So this is something we do in FreeNAS because FreeNAS supports iSCSI. But again, once you have a volume, you just say create zvol, you give it a name, and you set the size. It needs to know the size of the space that you're going to be formatting. And you click Add zvol. Snapshots, Chris talked a bit about. Really nice thing about snapshots is they are very low cost. They're instantaneous as soon as you take a snapshot, and they are of no size until your data changes. So you basically get a snapshot at that point in time, and as time passes, you can see the differences in the files. Snapshots can be recursive, so you can recurse through the children data sets. And that recursive is atomic, so it all occurs at the same time. Because it's copy on write, the initial size is 0 bytes. It only grows as disk blocks change. And as Chris was demonstrating, these can be replicated to another system. In FreeNAS, as soon as you create a volume, you can go in and set a schedule for when you would like snapshots to occur. You select the volume, or you can choose to just do an individual data set. You can select whether you want to recurse through children data sets. You set a lifetime, how long it's going to live on the local system, and then you set a period of time when it occurs. And typically, if you're in a business scenario, you'll have your snapshots occur during the times when data is actually changing on the system. So if users are only on the system from 9 to 5, you can set your snapshots to occur during that time. And you can set the days of the weeks and how often the snapshots occur. On a PC-BSD system, we have a couple of utilities that support snapshots. So the first utility that Chris put snapshot functionality into was Warden. So if you're familiar with FreeBSD jails, Warden gives you a nice front end to managing and creating your FreeBSD jails. So on this system, the 3 jails have been created. Right now I've selected the FreeBSD jail, gone into its snapshots tab, and currently no snapshots are occurring. But I can go in and check to schedule snapshots and how often those occur. And I can go in and add as I want to. Once snapshots are starting to be created, this will turn into sort of a time machine slider where you can slide through the various snapshots, and you can choose to restore or mount or unmount snapshots in order to access their data. Chris was showing you how this has also been put into the life preserver. Excuse me. So similar to the screens he showed you, you can go in and set your schedule, you can set your pruning, so how long to keep your snapshots. He showed a little bit on the restore. So again, some of this you've already seen. I'm going to show another picture of the browser and how easy it is to actually restore your files. You can replicate to another system so that you can use that to restore a system. So Chris was showing in the restore data screen. So once you set up your snapshot schedule, you have a couple of ways to go through your data. So you can scroll back in time or forward in time. You can use the slider, and you can specify where in the directory structure you want to look at. So right now I happen to be in my home directory, and it's basically just a graphical ls of the contents of the home directory at that point in time. The really cool thing is say I'm doing snapshots every 15 minutes, and I'm thinking, and I'm editing through a file as I'm writing documentation, and I'm thinking, that change I made an hour and a half ago, I wish I hadn't deleted that. I can scroll through that point in time, like go back every 15 minutes, find that file and click restore. It's not going to overwrite the current copy of my file. It's going to give it the same name with a BCK extension. And if that wasn't the version that I wanted, I can go back another 15 minutes, restore that file, look for that change. and it's going to restore that with a BCK1 extension. So I could actually go through 15-minute increments of that file looking for the change that I needed. Because snapshots are so low cost, it doesn't hurt to do things like take snapshots every 5 minutes. And if you need to, you can go back in 5-minute increments and find versions of files. And it's very graphical, very easy to use. So does anybody think that's useful? And I'm not aware of any other OS that does anything even close to that, to be able to grab what you need. This was the screen Chris was showing you from, so if your machine totally blows up, gets lost, stolen, you want to actually clone your current system to another system. If you have been sending, replicating those snapshots to another system, you just click restore, starts a nice little wizard that basically asks what's the IP address of that system and what's the password. You'll then get something very similar to this. It's not going to show you on the file system level, but it's going to give you a listing of all your snapshots and their timestamps, so you can decide at what point in time do I want to restore this system. And it just works really easy. Nice point and click. Some of the features I was mentioning before, even if you make a zvol and you format with another file system, you still get the benefits of ZFS, and one of those benefits is scrubs. So ZFS was designed to be self-healing, so as it is writing data, it's creating checksums on those disk blocks, and as it's reading data, it's verifying those checksums. And if it happens to come across a checksum that doesn't match, it will try to find a valid copy of that file or that disk block in order to fix it. So it's always trying to protect you from corrupt data. One of the things that's recommended to do, so this happens as you read and write, every time you read and write. You also want to do something known as a scrub, because there will be areas of your disk that you have data written that you're not reading regularly. And a scrub is going to go and verify the checksum for all of your used disk blocks and to see if you have any checksums that don't match. Again, it will attempt to correct data as necessary if it finds checksum mismatches. When you're doing a scrub, it is a bit I/O intensive, so you should be scheduling it for a time when you're not using the disk heavily. And there's no sense doing scrubs if you're not looking at the results. So a scrub can give you an early indication that you have possible disk failure in your future. So if it's starting to find a lot of corrupt disk blocks, that's something you want to be aware of ahead of time. And the scrub will tell you that. In FreeNAS, as soon as you create a pool, a scrub is automatically scheduled for you. It's scheduled for Sunday at midnight. If that happens to not be an appropriate time for your organization, you can go in and change the time. On a FreeNAS system, if you want to see the results of your last scrub, if you like to do it from the GUI in volume status, it will actually tell you when the last scrub was run and if there were any errors. And if you're a CLI person, you can just type zvols status. And you can initiate a scrub. You don't have to wait for the schedule. We do have a view volume screen that has a button to start a scrub. In PC-BSD, you can either go into that disk manager utility or life preserver. So we'll just take a look at some quick screenshots. So here in volumes, I have a volume 1, and under ZFS scrubs, there's already a schedule created for volume 1. It's a little hard to see because it's small, but it's basically happening at Sunday at midnight. I can click on that and change that time. And on a PC-BSD system, if I'm in Life Preserver, I can just go in the Disk menu and start a scrub. Life Preserver will always show you the results of the last scrub, and green means it was okay. If this ever shows as red, it had some errors, so you're going to want to take a look at your zvols status. The other property that a lot of people were waiting for, and then they realized it wasn't quite what they wanted when it finally came, was deduplication. So deduplication on the surface sounds really cool. Basically, ZFS will try to avoid writing duplicate data. So if you're doing things like creating a lot of virtual images, you have a lot of duplicate data. With deduplication on, it can improve your storage efficiency. Unfortunately, it's going to be at the price of performance. It's very intensive to figure out as you're creating something if it is duplicating any other disk blocks. So if your goal is to use as little storage space as possible, compression will do that for you with very little performance impact. So we typically recommend that people do compression first and see if that's enough for you. One of the reasons why deduplication may not be good for you is the tables that are tracking the disk blocks, the dedupe tables, have to fit into your ARC L2 ARC. And terrible things happen when those tables get bigger than that. General rule of thumb is 5 gigs of RAM per terabyte of storage to be deduplicated. Yes. Yes. And again, Chris has already touched on this, and he did a very good job explaining the boot environments. So basically, it takes no cost to create a boot environment. It takes all of 2 minutes to create one, and that's just getting to the screen. So basically, if you're ever going to do anything that could be possibly risky, so you're ready to upgrade the operating system, you're going to go and install a bunch of updates or patches. Other things you can do with boot environments is if you are creating a development environment and you want to start playing around with things, create a boot environment first, which will preserve what you already have. As Chris demonstrated, they go right into your boot, into the GRUB boot manager, and all you have to do is reboot and go back to a good known state if you have a problem. So this is a screen Chris showed you in control panel. You already have a default boot environment, and to create a new one, you click plus, you give it a name, it takes all of half a second, and everything is good to go. And again, as Chris showed you, it just shows up in your boot menu. Okay. We have a whole bunch of additional resources, so both PC-BSD and FreeNAS have very comprehensive user guides. The ZFS Best Practices Guide has a lot of good information if you're setting up a pool for storage. And if you prefer to watch videos, Becoming a ZFS Ninja is a very good video. And I'll actually leave you with this slide, which has the URL to this slide. So if you missed any URLs along the way, and my contact info. And yes, we have 15 minutes for questions. Anybody has any questions? Or any comments? I'm always nervous, giving a ZFS talk in front of Matt. So. I know both Jen and Josh at iSCSI have done a lot of that. And I know when they're working with customers, figuring out the best hardware, that those were the ones that they came up with. So I'm not really the hardware performance person, but they said they've gotten the best results from those. So I'm curious as to what your thoughts are on that. It would be interesting to talk with them because I think right now we just have one block size and we don't let you change that. So in zvols we let you change the block size, but for the pool itself, no. And I don't know if their findings are for that particular block size. We recommend people use compression because especially with LZ4, it's like no cost. Okay. I'll talk to them more about that. Thank you. Anybody else? Yeah. But you still need the backup of your other data sets. Yeah. PC-BSD, no, but not from the GUI, yeah. But in FreeNAS, yes. Now right now in FreeNAS, we're rewriting our replicator, and it will not let you replicate, if you already have a parent volume replicating, it won't let you replicate the data sets. Right now that's a limitation of our replication system. So if you just wanted to schedule them, that's fine, but you wouldn't be able to replicate them.